All right, buckle up, guys. This one is a lengthy section. This is our first section for Math 1613. 5.1, just angles. All right, so we're going to talk about drawing angles in standard position, converting between radians and degrees, converting radians degrees to degrees minutes seconds, coterminal angles, lengths of arcs, areas of sectors, and linear and angular speed. So we're going to start with some basics, drawing an angle in standard position. So, definition of an angle. An angle is the union of two rays having a common endpoint. That endpoint, that's called the vertex. The two rays are the sides of the angle. So that means E is my vertex, and ray ED and EF are the sides. Now, whenever you name an angle, the vertex is always the middle point. All right, an angle is in standard position. If its vertex is located at the origin and its initial side extends along the positive x. So an angle is a ray that's rotating counterclockwise. And if you're able to, I want you to highlight or underline this. Counterclockwise is a positive angle. So when I'm looking over here, I can see my initial side right here along the positive x-axis. My terminal side, this is the side that's doing the rotating up here, where E is the vertex. If an angle is rotated counterclockwise, or regular clockwise, I don't think that's a word, clockwise, then it is a negative angle. What is my deal here? There we go. The negative just represents the direction that you rotated. Positive is counterclockwise, negative is clockwise. We also use several different angles or several different Greek letters to represent angles. This is the primary one here. Phi or phi, alpha, beta, gamma. Okay, I cannot draw this one. I don't know why. And I struggle with gamma, but the rest I can do. All right, the measure of an angle is the amount of rotation. So it's the amount of rotation from the initial side to the terminal side. Okay, our current measure is degrees. So there's 360 degrees in a full rotation of a ray. Angle measures are considered fractions of a full rotation. So that means 1 degree is 1/360th of a full rotation. We'll talk about these fraction pieces, and that's how angles are measured. Okay, it's fraction of the whole. All right, so whether it's degrees, 1 out of 360, or when we get to radians, 1 out of 2 pi. Okay. An angle is quadrantal. You see that word quadrant in it. If its terminal side lies on an axis. All right, so our major ones, 0, that's right here. 90, terminal side's on the positive y. 180, terminal side's on the negative x. 270, the terminal side is on the negative y. And then all the way even around to 360 where it's back to the positive x. All right, so sketching. If we're in degrees, we can simply kind of compare to our quadrantal angles. Things like, is it close to 90? Is it close to 180? Is it close to 270? Is it negative? So like on 30 degrees, I know that's going to be between 0 and 90 degrees, closer to 0. So we have your initial side. Then we have our terminal side. And then you draw the rotation and label. All right, now, negative angles. All right, since we're going this direction, we have to think of the quadrantals backwards. So instead of 90 degrees being up here, negative 90 is down at the bottom. Then we have negative 180, negative 270, and then of course back around down to negative 360. All right, so negative 135 degrees is going to be between negative 90 and negative 180. So we still have our initial side and our terminal side somewhere in between. I don't know exactly where just because I'm not measuring it. I'm just estimating. Label your rotation. You have to show that. And then list your angle. All right, 240 degrees. So it is positive, so we are going that direction. And 240 is awfully close to 270s, and 270 is down here. So I have my terminals, or my initial side. And then I have my terminal side. Draw your rotation. Label your angle. All right, negative 315. Again, negative 90 down here. Negative 180. Negative 270 in the background to negative 360. So I can see that that negative 315 is going to fall somewhere in between negative 270 and negative 360, probably closer to that negative 360. So we have initial, and then we have terminal. Now, the key here on this one is the rotation, all right? Because if I rotate up, that's this little bitty angle. That's not what we want. We want rotating the other direction. And then don't forget to label. All right, now we're going to talk about a different measure of an angle called a radian. So we've done degrees. All right, degrees is the amount of rotation. A radian is based off arc length. So a radian is a central angle whose arc length is equal to the radius, hence the name radius, radian. So here's my radius. If I were to transfer this length to the arc itself, these two would have the same measure. So that means this is 1 radian, definitely larger than a degree. Okay, circumference has to deal with circumference. Again, arc length. Circumference represents the full arc length of a circle, which is your perimeter. All right, remember our formula for circumference is 2 pi times the radius. And then if the radius is 1, okay, the radius is 1, 2 pi times 1. So it means 1 full rotation is 2 pi radians. Okay, so 1 full rotation all the way around is 2 pi radians. What would half a rotation be? Well, that would be pi radians. All right, so therefore, that means 2 pi radians equals 360 degrees. So we're going to attempt to find the measure of a radian, okay, in degrees. All right, so I'm basically solving for radian. All right, I want radian, 1 radian, not 2 pi. So I'm going to divide by pi. Divide by 2. Then I'm going to divide by pi. I'm going to do that in the calculator. 1 radian equals approximately, do my approximately symbol, it's the little squiggles, 57.296 degrees. How is arc length related to that? All right, well, we'll cover it here like officially in a little bit, but arc length, S for arc length, R for radius, theta for angle. So S R for in radians. might remember. All right, so I'm going to solve for theta here, which means I'm going to divide by r. I'll kind of switch them around. Theta equals arc length divided by radius. Well, a radian is when the radius equals arc length, which means S equals R. So I can sub R for that S. Therefore, theta equals 1 radian. A couple of notes here. Oh, well, actually, just one note. So we have units. We have angles in degrees. We have angles in radians. If you see an angle that's listed without a unit of measure, they are radians. Okay. All right, so 1 radian. Then we have 2. And then we have 3. So 3 radians takes me to almost a half a circle. Okay, well, if you remember, the decimal equivalent for pi is 3.14. So you can see that a little less than that. That would be your 3 radians. When we go all the way around, they're just a little bit more than 6 radians. Okay, so some key angles that we're going to talk about. Okay, these are special angles. We know that 1 full rotation is 360 degrees. Okay, we know that half a rotation is 180 degrees. Well, what is 1/4 of a rotation? Okay, well, that would be half of 180. That would be 90 degrees. So talking about in radians, half of 2 pi is pi. Half of pi over 2. All right, so these give us our quadrantals for the most part, right? Even 270 is a fraction out of the whole. It's 3 of 4. So how many of these angles do I have? If we count, we have 1, 2, 3, 4, 5, 6, 7, 8. So it took 8 to make a full rotation. How many they make up half a rotation? 4. All right, so 1/8 of a rotation equals 360 divided by 8. Actually, I'm going to put this over here. Which is 45 degrees, which is pi over 4 radians. Well, how many of these angles make up pi over 2? We know pi over 2 is 1/4 of a rotation, so that's up here. So it took 2 pi over 4s. All right, we're starting here. This is 0. And if we count, this equals 2 pi over 8, pi over 4. So I'm going to start counting by pi over 4. So this is 1 pi over 4. This would be 2 pi over 4. That one would be 3 pi over 4. Okay, so we're talking about fractions. So these angles to equal this one. If we keep going, that's 4 pi over 4. So pi, which we already knew, that's half a rotation. If we keep going, 5 pi over 4. 6 pi over 4. So that's 3 pi over 2. 7 pi over 4. And then one more, so all 8. 8 pi over 4, which is your 2 pi. All right, so we're kicking it back to like elementary school when we used to talk about fractions as pieces of pie. Literally pieces of pie here. All right, so sketching these angles in standard position, 3 pi over 4. Okay, well, I know it takes 4 to make up that top half, so 3 pi over 4 is somewhere in here. And it's exactly halfway between, which I'm not going to sketch perfectly, but it is what it is. Okay, and then I've got 5 pi over 4, so it took 5 of them. Well, I know it takes 4 to go half a rotation around, so 5 puts me in here. Well, negative pi over 4, that's clockwise. I'm going down the other way. It still takes 4 to make that down half. I only have 1 of them, so that means I am here. That's terrible. All right, negative 3 pi over 2. All right, it takes 4. All right, so 2 gives me negative pi over 2. 4 gives me negative pi. 6 gets me my negative 3 pi over 2. Now we're going even smaller. So I have a bunch of pieces here, and how many of them make up that full rotation? All right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it takes 12 for a full rotation. For a half a rotation, that means it's a 6. All right, so 1/12 of a rotation, 360 degrees divided by 12 is 30 degrees. Well, that means in radians, 2 pi divided by 12, 2 goes into 12 6 times, is pi over 6. All right, we use the half rotation for the denominator. All right, well, how many of these angles make up pi over 2? Okay, well, I know pi over 2 is here, so how many did it take? 1, 2, 3. All right, again, just talking about fractions here. So if we start at our initial side, this is 0. Okay, so that's 1 pi over 6. And we've got 2 of them. 3. And you guys get the drift from here. 4. 5, 6, 7, 8, 9, 10, 11, and then 12. Again, talking about pieces of pi. All right, so if I want to graph 5 pi over 6, all right, I will compare it to where pi is. Pi is 6 pi over 6. This is 1 less than that. Quit moving. So that means I'm falling somewhere here. And because it's so close to 6, I know I'm going to be pretty close. All right, 11 pi over 6. Again, we're talking about negative directions here. All right, so that means down here we're negative pi over 2. All right, remember it takes 3 of these 6's to make a pi over 2. It takes 6 of the 6's to make negative pi. It takes 9 for negative 3 pi over 2, and it takes 12 for negative 2 pi. All right, I need 11. So that means I'm going to fall somewhere in here with the rotation of that direction. So initial side, terminal side, rotation, that's terrible. Negative 11 pi over 6. All right, so our key angles that we've done so far, we've done a quarter of a rotation, 90 degrees, or pi over 2. We've done an eighth of a rotation, and just being pi over 4. We've done a 12th of a rotation, pi over 6. So our last major angle. Okay, how many of these angles make the full, ooh, this is backwards. We're gonna do this one first. How many of these angles make the full circle? Okay, it takes 1, 2, 3, 4, 5, and then 6. How many of these angles make the semicircle? So half of that, would be 3. All right, so that means 1/6 of a rotation, 360 divided by 6, 60 degrees. Or 2 pi divided by 6, which is pi over 3. And again, you can see how that's related. That 3 is that semicircle. Okay, how is it related to pi over 6? If we go back and look at a pi over 6, you can see pi over 3, right? How many pi over 6's did it take to make the pi over 3? It takes 2. And then we sketch 5 pi over 3. Actually, let's go ahead and do this. So this is 1 pi over 3. All the way around. 2 pi over 3. 3 pi over 3, which is pi. 4 pi over 3. 5 pi over 3. And then 6 pi over 3, which is your 2 pi. All right. Doesn't relate to the pi over 2 because it doesn't, takes 1 pi over 3 is too small and 2 pi over 3 is too big. So if I want to draw 5 pi over 3, I know 6 pi over 3 is here. So 5 pi over 3 must be there. And one thing to help you with these special angles, if your new pi is almost double, it's going to be in your quadrant 4. Right. If it's 1 less, so if I wanted to draw 4 pi over 3, if it's 1 more than its denominator, it's going to be in this quadrant. If it's 1 less, quadrant 2. And if it's just pi, we're in quadrant 1. All right, 4 pi over 3. Okay, so I already know that negative pi is over here, and negative 2 pi is back over that direction, and we have to go this way. So all of our rules kind of flip. All right, this would be 1, this would be exact. This would be 1 less than denominator. This one would be 1 more, and that one would be almost double. So this is 1 more. That means I'm falling in that quadrant. You'll also notice that your pi over 3's are closest to your y-axis, and your pi over 6's, let me finish labeling that. So your pi over 3's are closest to the y-axis. Your pi over 6's are closest to the x-axis. All right, our next section is converting between radians and degrees. So the relationship between a degree versus radian is its proportion out of a semicircle. It'd be the easiest. So we take theta out of 180 over theta radians out of pi. And you cross multiply. So to go from radians to degrees, multiply by 180 over pi. To go from degrees to radians, multiply by pi over 180. So convert the following angles to radians. All right, well, we have our theta, which is 15 degrees, over 180, equals theta over pi. What happens here, and this is why you can change from degrees to radians, is your degrees actually cancel. And you would cross multiply. And then divide by 180. Now, if you're not sure about this, you can do that part in your calculator. Just don't put the pi in. We have fraction bars. So on my calculator, it's alpha y equals enter. Then we do 15 and then 180. Let's see, and then math 1. So 1/12. Okay, and that's why it works. And most of the time, I'm probably not going to do that. Your theta in radians equals 150 degrees times pi over 180 degrees. That's the easiest way to do it. Degrees cancel. And then your zeros will actually cancel because it means you were able to divide by 10. And then 15 and 18 can both be divided by 3. So we get theta equals 5 pi over 6. Okay, 400. 400 degrees times pi over 180. Degrees cancel. 0 cancels. And then let's see. 40 and 18 can both be divided by 2. So that's 20. That's 9. So 20 pi over 9. Okay, negative 126. Degrees cancel. Let's see, I think the most I can say right now is that 2 goes evenly into it. So 2 goes evenly into that 90 times, and into that negative 63. And both of those can be divided by 9. So that's 10. That's negative 7. So theta equals negative 7 pi over 10. Again, if you're not sure, I'm going to go to my calculator, do negative 126 over 180. Okay, that'd be math 1. So 7/10, so I was right. All right, this one we're going the other direction. These are radians. And I know they're radians because, well, number one, it tells me. But there's no degree. All right, so our theta in degrees equals our angle times 180 over pi. Going from radians to degrees. Okay, pi 180, it's 180 degrees. 6 goes into 180 degrees 30 times, so theta is 30 degrees. So angle times 180 degrees over pi. So this one's not going to reduce. You're going to have this pi in the denominator, which is fine. I just don't know what 3 times 180 is. Let's see, 3 times 180, 540. And that's fine to get. And if you want to do it as a decimal, you do that divided by pi. So 178.887, 171.887. Again, make sure you put your degree symbol. Negative 3 pi over 4, so theta equals your angle, times 180 over pi. Pi cancels. 4 actually goes into 180 45 times. Yeah. And then negative 3 times 45. Negative 90, negative 135. I don't like that 3. And 7 pi over 2. So your angle times 180 degrees over pi. Pi cancels. 2 goes into 180, 90 times. 7 times 9 is 63, so this would be 630 degrees. All right, I kind of have my picture and my definitions backwards here, but what happens when you sketch an angle is that you have this possibility of something called a coterminal angle. So angles in standard position with the same terminal side are coterminal angles. So I'm gonna look at this one. This one's a really good example of this. All right, initially, here's my terminal, or my initial side right here. And there's my terminal side. Okay, if I didn't see any of this, oh, that's easy. My angle is 38 degrees. Okay, but that's only one option. Okay, rotating that counterclockwise. What if you rotated clockwise? Right now my angle is that negative 322. It's the same drawing, different angle measure. Right, looking at something like this. Here's our initial and terminal side. And this one, they give you way more. We have our little bitty one, pi over 3. Okay, we have going clockwise, negative 5 pi over 3. Then we also have going more than one rotation around, 7 pi over 3. They all start and end at the same spot. They just have different values. All right, think of it like going another lap around. Same thing's happening on this one. You have your initial side and your terminal. So we're little bitty, 45 degrees, going counterclockwise. You've got your negative 315 going clockwise. You can also do going around more than once. Now you can keep going around and around and around and around all you want. But they all have the same start and stop. All right, so to find coterminal angles, you rotate around the circle over and over again, either counterclockwise or clockwise. For degrees, you add and subtract 360, and you keep going until you meet the criteria. For radians, add or subtract 2 pi, and then you keep going until you meet the criteria. Just make sure you read the directions so you know your criteria. All right, so find an angle between 0 and 360 degrees, or between 0 and 2 pi. That's coterminal with your given angle. So 965 is obviously bigger than 360. All right, so I'm going to take 965 and subtract 360. So it's 605. That is not between 0 and 360, so I'm going to do it again. That one is. So 245 degrees. Okay, now let's talk about this guy. All right, this is negative 3,287. All right, this is intense. All right, this is 4 place values. So what I would do with this one, okay, I'm going to give you kind of a way to do it. You're going to divide your angle by 360 degrees. Okay, so we get 9.1, give or take. If angle is negative, round up. So this is going to be 10. Okay, multiply 360 by your value. Then add to angle. Okay, so let me show you what that means. Okay, we did negative 3287 divided by 360, and we got 9.1. So I'm going to round that up to 10. And I'll multiply 360 by 10. Then I'm going to take that and I'm going to add it to my angle. So I'm just going to do it with my side calculator over here because I don't feel like going back. Negative 3287 plus 3600. The reason we round up if it's negative is because it wanted my angle to be between 0 and 360. Okay, if I did just 9, so 9 times 360, and we took that and we added, my angle would not be big enough. It would be negative 47. That's why we round up, because my angle has to be between 0 and 360. Okay, so let's do another one. This one's positive. Okay, so here's the deal with positive. Do the same thing. Divide angle by 360. So 8247 divided by 360. So 20.9. Wait, what does that say? 22.9. If angle is positive, round down. This is going to be 22. Multiply by 360. Then subtract. All right. So we're doing 8247 divided by 360. 20. Okay, we're going to multiply that by 360. And then we're going to subtract. Okay, now in radians, I don't do any shortcuts with radians because of the fraction part of it. But what I do is I make a common denominator with 2 pi. Because right now it's over 1. And since I had to add or subtract, I need a denominator 18. So 1 times 18. Let's multiply bottom by 18, multiply top by 18. So 36 pi over 18. All right, and you want an angle that's between 0 and 2 pi. All right, so 37 is a little bit more than 37. So this is going to give me 1 pi over 18. All right, because it would have to be between 0 and 36 pi over 18. Okay, 7 pi over 18. So I need to subtract. So let's do the same thing on this one. We have to multiply by 9. So we can see that 23 is bigger than 18, so I need to subtract. That's going to give me 5 pi over 9. Okay, let's get our last one. To multiply by 6. All right, now this one is negative, so I'm going to have to add. And we get negative 5 pi over 6. My answer has to be positive, so I got to do this again. So that is going to give me 7 pi over 6. Okay, sketching these types of angles, I'm going to compare to 360 or to 2 pi. 390, okay, that's big. I'm going to subtract 360. It puts me at 30 degrees, which means my angle is terminating in quadrant 1. Okay, so it's going to go all the way around and a little bit more. Okay, 19 pi over 7. All right, I'm going to compare this to 2 pi. All right, if I take 19 pi minus 14 pi over 7, that's going to give me 5 pi over 7. Okay, so that's not quite... I just lost my train of thought. It's not quite all the way around the circle. Okay, so this one's a little weird. All the way around the circle is 14 pi over 7, which means half of that would be 7 pi. Oh, that's terrible. Over 7. Well, half of that would give me my 90 degrees, 3.5 pi over 7. So 5 pi over 7 has to fall somewhere in here. I don't know what's going on. Let me erase it. Okay. So initial side, terminal side. I don't know where in there it is, but I know it's in there. So this terminates in quadrant 2, all the way around, plus that little bit more. Okay, remember your quadrants. 1, 2, 3. Give me that.